Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome to Forward Public School e-learning class 10 subject chemistry chapter number 9 chemical equilibrium. Today's topic is forward and reverse reaction, chemical equilibrium and its graphical representation. And here is your teacher Mehreen Zafar. We will start our topic from forward reaction. How can we define forward reaction? That is the conversion of reactants into products per unit time is called as forward reaction, or we can say that the rate of a chemical reaction takes place in the forward direction is called forward reaction. When reactants combine together, they give you the product, so the reaction moves in the forward direction. Such type of reaction is actually called as forward direct reactions. Here we have some example. Nitrogen, when reacts with hydrogen, they will give you ammonia. NH3 is the formula of ammonia. So NH3 is ammonia. Here we have another example. When hydrogen reacts with iodine, they will give the product hydrogen iodide. So these two reactants react together and give you the product hydrogen iodide. So it means that the reaction goes in the forward direction. Now we will discuss reverse reaction. By definition, reverse reaction is the conversion of products into reactants per unit time is called reverse reaction. It means that with the passage of time, when products are converted back into reactants, such type of conversion is called reverse reaction. We can define it as well that the rate of a chemical reaction which takes place in reverse direction is called as reverse reaction. Here we have some example. Here we are taking ammonia. Ammonia get decomposed into nitrogen and hydrogen. So the chemical reaction is actually moves in the reverse direction. Here we have hydrogen iodide. Hydrogen iodide similarly decomposes into hydrogen and iodine. So if you compare the example of forward reaction with the reverse reaction, you can clearly get the idea that what is a forward and what is a reverse reaction. Now we will do the macroscopic correct properties of both reverse and forward reactions. As the name shows, forward reaction in which the reactants reacts to form the product, while reverse is a chemical reaction in which the product reacts together and they form the reactants again. Second point is forward reaction always takes from left to right, while reverse reaction takes place from right to left. Third point is at initial stage, in the beginning, the rate of forward reaction is very fast, while in case of reverse reaction, the rate of reverse reaction is zero, or we can say negligible. With the passage of time, forward reaction slow down, while reverse reactions speed up. Now we will discuss chemical equilibrium. Chemical equilibrium is a condition which develops when the rate of forward reaction becomes equal to the rate of reverse reaction and the concentration of both reactants and products remains constant. So if we can show it like this, that in such condition the rate of forward reaction becomes equal to the rate of reverse reaction, but the concentration will remain constant. There will be no change in the concentration. This point is very much important, students. You have to memorize it very well. Now, how can we represent graphically chemical equilibrium? For this, we are taking a general example. A and B, when reacts together, they give you the C and D products. Initially, the concentration of A and B is taken same and maximum, while that of the concentration of C and D, which is the product, that is at 0. So as the forward reaction moves, A and B react together, they will start forming the product C and D. So the concentration of A and B will start decreasing, while that of C and D start increases. But in case of reverse reaction, the concentration of C and D will start decreases, while that of A and B will start increases. But this condition applies only on reverse direction, when the reaction moves in this direction. Here we can clearly see that in reverse direction, the concentration of reactants A and B increases, while the concentration of the products, that is C and D, it starts decreasing. After some time, a condition develops in which the rate of forward reaction becomes equal to the rate of reverse reaction, and the concentration of both forward and reverse reaction becomes constant. So such condition is called as chemical equilibrium. Graphically, we can see that if we plot reaction rate versus time, we can see that this graph is plotted for a chemical reaction. When hydrogen reacts with iodine, it forms hydrogen iodide. In the initial state, the rate of forward reaction is maximum, but with the passage of time, it starts decreases. In the same way, at the beginning, the reaction rate, the speed of the reverse reaction is slow, but with the passage of time, it starts increases. A time reaches when the rate of forward reaction and backward reaction becomes equal, and we can say that equilibrium has been established. Now, what are the factors which affect the dynamic equilibrium? Following are the factors, that is pressure, temperature, and initial concentration of gaseous reactants and products. If we do not disturb these conditions, the system will remain in equilibrium, but if we disturb the conditions, then definitely equilibrium will disturb and the reaction will either move in the forward or reverse direction to regain the equilibrium. Here are examples. Nitrogen, when reacts with hydrogen, this will give you ammonia. Similarly, mercury oxide decomposes into mercury and oxygen. So how can we write a chemical reaction, forward and reverse reaction for any given reaction? We are taking the example of ammonia. Ammonia decomposes into nitrogen and hydrogen. So we can write forward reaction as nitrogen get decomposed into nitrogen and hydrogen, while reverse reaction will be nitrogen and hydrogen react together and they give you the synthesis of ammonia. Here we have another example. When nitric oxide react with oxygen, they will give you nitrogen dioxide. So forward reaction can be written as nitrogen oxide reacts with oxygen, they will give you nitrogen dioxide, while reverse reaction will be nitrogen dioxide decomposes and give you back the same reactants, nitrogen oxide and oxygen. Now here we have assessment for the students. Do practice problem 9.1 on page 6 of your book in your rough notebooks. Thank you for your attention. Stay home, stay safe. Thank you.